Welcome to session 9 of the Introduction to Computing Csit 103 class. In session 9, we're going to continue the networking concepts which we have earlier on, and this time move on to the major hardware, the network hardware, which let the networking activity happen. So network devices are integral components that help you manage the availability, performance, and security needs of your network resources. Most basic of networks require devices to provide connectivity and functionality. Understanding how these networking devices operate and identifying the functions they perform are the essential skills for any IT student must have. We will now describe some aspects of the networking hardware, including the fact that networking is an environment supporting computing and sharing of files and resources. Then we also look at the components of the hardware we would need in setting up a network. Then to enable communication among computers, we need some hardware. Each computer on a network, in a network we have 2-3 computers together, or a list of links computers together to communicate and share. Each computer on a network needs a network adapter. A cable is needed to hook computers on the network together. Connectivity devices are needed to attach several computers or network to each other. Need to connect LAN to LAN or WAN. We have different types of network as we explained in other sessions. We have LAN, we have WAN, and we have MAN, where we have one LAN and we have another LAN. Or you want to connect a LAN like University of Ghana LAN, local area network, to a WAN, such as the Internet, or such as the another KNUST LAN. We need a hardware called hub for connecting computers within a LAN. We have a hub which helps the University of Ghana connection to be possible. All computers are connected to this hub to enable them communicate. Then we have a bridge which connects two LANs, like a LAN of University of Ghana to a LAN of KNUST, so that we can share some of the resources from another place. We have a switch which connects segment of a LAN. We pick part of a LAN in University of Ghana, like a business school LAN, and then we connect it to another LAN like the nursing or computer science LAN. We make use of what we call a switch. So switch connects segments of a LAN. Then the last one we'll look at is the router. For router, you are connecting a LAN to a WAN. Let's say you are connecting the University of Ghana to the internet setup. Why interconnect? To separate or connect one corporate division with another. To connect two LANs with different protocols. To connect a LAN to the internet. To break a LAN into segments to relieve traffic congestion. And to connect wired LAN to LAN. So network hardware is what we call the network interface card, NIC, as shown there. It is a card always, now you can have a port for it, and it's on the motherboard, and then it supports your any computer system without a network interface card can never be used in networking. Take notes. It prepares, sends, and controls the flow of data. It receives and translates data into bytes for the CPU to understand. You know, computers talk or deal with machine codes. So this is what it is explaining here. Modem is one of the hardwares responsible for modulating and demodulating digital signals into analog signals. What we are dealing with in the networking infrastructure, we are using telephone switch, telephone lines, and telephone lines are naturally analog. So we use in computing or in digitalizing this setup, we make use of an modem. Modem simply means modulator, demodulator, and it works in two functions. It has modulating component and demodulating component. In the demodulating component, it changes the data into the digital data into an analog setup, and then it's able to transfer it through the telephone switches or telephone lines we use. Then at the receiving end, it changes the data back from analog to digital for the reception to take place. So this is why we have modem, two major design or this system. Responsible for moderating and demodulating digital signals into analog signals that can be passed over telephone lines. Can be used to connect a network or the internet using phone lines and a dial-up connection. Modems provide flexibility, but it is a slow setup. This is a typical modem. The fastest modem transfer data at 56 kilobytes per second. And this is where the back of the digital subscriber line or the DSL modem. Access points. Any point that allows a user onto a network is termed as an access point. So any node or any where any workstation sits. Commonly used in reference to wireless access points, which enables a user connect to a network via an 802.11 technology. Hub interconnects two or more workstations into a local area network. So hubs are used mostly within a LAN, a local area network. It expands one internet connection into many. So we have example as the picture shown over there. This is a hub. It's responsible for sending a signal to all stations connected to it. There is a competition among computers, devices on this device for data. Traditionally, hubs are used for star topology networks, resides on layer 1 of the OSI model described earlier. This is a typical star technology or topology setup, and the hub is the one in the middle, and all other stations or nodes are hooked onto the hub. So this we say is 5-port or even more hub connects up to 5 or more machines. We can have more machines, but as it is, we have 5 machines. So it's a 5-port. Then we look at a bridge. A bridge is also another device used for connecting two LANs operating usually under the same protocol. So there are bridges that connect LAN segments operating under different protocols also. Connects networks and forwards frames from one network to the other. This is where I said we have two different LANs, two independent companies or branches. Assuming we like the banks, we have 2 branches in Accra. They can be connected to with a bridge. Bridge connects 2 LANs and forwards or filters data packets between them. It creates an extended network in which any 2 workstations on the link LANs can be shared data. Transparent to protocols and to higher level devices like routers. Forward data depending on the hardware, that is the MAC address, not the network address. Resize, every computer has a unique address. We call it MAC. This is the address it's talking about here. So when you forward the data MAC address is what it looks for. Resides on layer 2 of the OSI model. So this is a typical bridge setup. We have one LAN here and another LAN here. We have 2 LANs hooked together with this bridge. This is another example. We have a bus topology with a bridge hooked 2 LANs together. If A sends a frame to E or from one LAN to the another, frame must be forwarded by this bridge. So it's the bridge that will be responsible for doing this forwarding. If A sends a frame to B, no need for bridge to forward the frame. If the frame is within one LAN, it doesn't affect the bridge. It is within the one network, a hub or any other, depending on the topology, it's just moved directly. But when there is data from one end of a LAN or one LAN to the other, or one physical location to another physical location somewhere, that's where we need a bridge for bridge to just forward the data. The bridge needs a database that contains information about which hosts are on which network. So in a bridge configuration, there's a database setup that supports this activity. The system administrator can create and maintain the database, or the bridge can acquire the database on the fly. Bridge versus router. A bridge is a device that connects two segments of the same network. Bridges are protocol independent. Router is a device that connects two distinct networks. When we say the same network in the bridge case, we are talking about LAN and LAN, man and man. But in a router, you can connect different networks. That is a LAN and a WAN. So a router is a device that connects two distinct networks. They are different networks. They are protocol independent. Forwards packets from one host to another. And routers are protocol dependent. Everything that happens, they depend on the instructions or the protocols concerned. Switches. It is a combination of a hub and a bridge. It operates a data link layer at layer 2 of the OSI model. It can interpret address information. It can interconnect two or more workstations, helps prevent data collisions, and reduces a network congestion. Switch isolates traffic patterns and providing multiple access. It divides network into several isolated channels. Isolation ensures that data goes only to the intended destination. It supports multiple data transfers at one time. It understands when two devices want to communicate. In such cases, a switch gives them a switch connection. Switch versus router. They are considered layer 2 devices, may be simply plugged into the network to use less latency. Router, they are considered layer 3 devices, provides a lot of services, route discovery, selecting best routing protocols, and others. Higher latency, requires initial setup to use between networks to route packets. So these are the main differences between routers and switches. We have repeater, used to regenerate signals to proper amplitudes and sends them to other segments. It retires signals as well. It boosts the signal between two cable segments or wireless access points. It requires a small amount of time to regenerate signals. This can cause a propagation delay, which can affect network communication when there are several repeaters in a row. So this is a repeater. Used for extending the physical span of a network. Span is often limited by design consideration also. Operates at the physical layer 1 of the OSI network model. Router, often called layer 3 devices. They operate at the third layer or OSI network layer, used to route data packets between two networks, that is two distinct networks in this case. Connect LANs operating under different protocols. Connect different sub-networks together. Router connects LAN to a WAN or a WAN to a WAN. A router accepts an outgoing packet, remove any LAN headers and trailers, and encapsulate the necessary WAN headers and trailers. Uses standardized protocols to move packets to their destination. More sophisticated than bridges. Forwards data depending on the network address, not the hardware MAC address. It allows for sharing a single IP address among multiple network clients.